All right, so we're going to go from our talking about parallel lines and transversals to talking about angles within triangles. And so we're going to start around our triangles. So we're going to start with the interior angles. So we have what is called the interior angle theorem. And the interior angle theorem states that the sum of the measures of the interior, forgot my eye on this one, interior angles of a triangle is 180 degrees. All right, so why? Why is that? How do I know that these angle 1, 2, and 3 is 180 degrees? So let's use what we learned in the last lesson. I'm going to tell you that T is parallel to BC. So, given line T is parallel to segment BC, and I extended this so that you can kind of see those parallel lines, and it's easier to see all the angles. Then, so since those lines are parallel, then the alternate interior angles are congruent, which means, so therefore, the measured, angle, here we go. Therefore, angle 4, right, is on this transversal here. I'm going to make it dotted. Angle 4 is an alternate interior angle with angle 2. So therefore, angle 4 is congruent to angle 2. And I use my other transversal, AC. I know that angle 3, which is my other interior angle, is an alternate interior angle with angle 5. So, and angle 3 is congruent to angle 5. So I know that much. And that's using what we learned from the last lessons. So from there, because I know that, and because of angle addition, the angle addition postulate, then by the angle addition postulate, right, that we learned in the first lesson, angle measure of angle 1 plus the measure of angle 4 plus the measure of angle 5 equals 180 degrees. How do I know 180? Because it's a line. They create a straight angle. Therefore, it's 180 degrees. Now, by substitution property, I can change 4 and 5 to the angles they're congruent to. Therefore, the measure of angle 1 plus angle 4 was congruent to angle 2, so the measure of angle 2 plus the measure, and then angle 5, right? Angle 1, angle 4, angle 5. Angle 5 is congruent to angle 3. So measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So therefore, the inside angles of a triangle equal 180 degrees. It doesn't matter what triangle. If I created parallel lines, or a line that was parallel to one of the sides, by alternate interior angles, I'm still going to get that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. So this is the main concept. The nice little wordy definition up here of interior angle theorem means this. Angle plus angle plus angle equals 180 degrees. Done. You don't have to do all of this in here on any of your problems. That was me explaining to you why. How do we know? How did they know? And that's how they figured it out. They took what they already knew and said, oh, well, this is true every time. All right, so moving on. Let's actually use this to find some angles. So here we have this angle 1 right here. I'm going to call it x. And so I know that x plus 32 plus 43 is going to equal 180 degrees. And yes, you could do the simple, add 32, add 43, and then subtract from 180. That's fine. I'm going to continue setting this up because this equation is going to help us for when we get expressions into our mix. So I'm now going to take 32 plus 43, so x plus 75 equals 180. Subtract the 75. So x will equal 105 degrees. And then that's it. Angle plus angle plus angle equals 180 degrees. Set it up, solve for our missing angle. So again, here we're looking for a measure of angle 3. I'm going to make that x. So x plus 50 plus 45 equals 180 degrees. I'm going to take 50 plus 45, so x plus 95 equals 180 degrees. And then I'm going to subtract 95. So x will equal 85 degrees. And so that's what I know. All right, so we've got a couple more examples, but I want our videos to stay pretty short and sweet, and then you can refer back to as you need. So we're going to have a, not an exception to a rule, but a shortcut to our rule in the next video. So I'll see you there.